Hello everybody, my name is Michael and welcome back. Going to be taking a look at the Mathematics for Computer Science course, and I'm going to also be making a video for the channel alongside. I thought I'd stream as well, just to kill two birds with one stone, as they would say. But let's go ahead and make sure I have volumes appropriate here for the course. Let me go ahead and put in my headphones, make sure we're all good here. And let's go ahead and get started. So just a quick recap. We learned about proofs last time, what they were, interconviction, sampling, method for asserting the truth as a proof through observing experimentation. We learned, mathematical proof, a verification of a proposition. A proposition is statements of true or false. So a verification of a true or false statement by a chain of logical deductions and a set of axioms. An axiom is a proposition that is assumed to be true and a set of assumptions to be true. And we just learned a predicate is something that depends on a variable. We have a couple of symbols here representing some just mathematical operation symbols that we saw in the last lecture, but also in the recitation problem, which I completed and did a tutorial on this channel. I didn't do the assignment. I went and did that independently and have been working on that. And I may or may not release a video. It's just rather long, so I like to keep things pretty short rather than just the lectures. So anywho, I'm going to go ahead and pull up the chat just in case anyone comes in. But I'm going to go ahead and just start recording here for the channel and begin. Alright, let's see, are we good? I think we're good. Alright. Hello everybody, my name is Michael, welcome back to the channel. We're going to be watching Lecture 2 of MIT's Mathematics for Computer Science for Fall 2010, more specifically the course 6.042J. Let's begin.
Is provided under a Creative Commons license. Your support will help MIT OpenCourseWare continue to offer high-quality educational resources for free. To make a donation or view additional materials from hundreds of MIT courses, visit MIT OpenCourseWare at ocw.mit.edu.
Last week we talked about the key components of a proof: propositions, axioms, and logical deductions. And as you probably talked about during recitation, we're not going to worry too much about what axioms or logical deductions that you use. Anything that is reasonable is fine by us. We're not going to ask you to know what modus ponens is or to label some law when you make a logical deduction. Just, be reasonable. Any fact you knew coming into this course about mathematics, probably close enough to use as an axiom. You want to make sure your axioms are consistent, but that's OK. Now, the exception to this would be, say we're on an exam and we ask you to prove some proposition P. Well, you can't say, I already knew P, it's an axiom, check. That's not so good. We're asking you to prove it from some more elementary facts. OK, it's also, you don't want to be making wild leaps of faith or saying it's obvious that unless it really is obvious. That kind of stuff can get you in trouble. Much better to sort of explain the reasoning in the proof. Now, the proofs that we covered last week in recitation and the problem set were all examples of what are called direct proofs. You start with some axioms, you have some theorems you knew before or you proved along the way, and you make logical deductions until you get to where you want to go, the theorem. We're going to start today with an indirect proof. For example, a proof by contradiction. And this is a little bit different. In a proof by contradiction, you assume the opposite of what you're trying to prove. Then you just take steps forward, logical deductions forward, until you arrive at a contradiction, something where you prove false equals true. Now, if you can ever get to the point where you prove something is false and true, that means what you assumed at the start had to be wrong. Namely, that what you're trying to prove has to be true. So let's write that down, because it can be a little confusing the first time.
Okay.
So to prove a proposition P is true, you will assume that it's false. In other words, that not P is true. And then you use that hypothesis, namely that P is false, to derive a falsehood. In other words, you prove a falsehood is true. And this is called deriving a contradiction. And so it must be that, in fact, P is not false, namely that it's true. Now, this works because if you can prove if not P implies false is true, well, from last time, the only way this is a true statement is if this is false, namely P is true. All right, so we can conclude that P is true if we can show that not P implies a falsehood.
Not P implies a falsehood. So use that hypothesis to derive a falsehood or contradiction. So proof by contradiction. To prove P is true, we must assume P is false. So we're going to first assume P is false in order to actually prove that P is true. So yeah, right? So if you want to say, well, pigs fly, right? Well, we need to first assume that pigs don't fly and then figure out why they don't fly. And then if we can't solve that, then they do fly. So derive a falsehood or contradiction. So if not P implies false, so if P being false means that, this syntax is so crazy. If not P implies false is true. If not P implies false is true.
Any questions about that? It's sort of a lot of sort of notation. And until you've seen it, it can be confusing.
How does no one in that whole class have a question? Not one of that whole lecture hall has a question on that?
Do an example.
Yeah, do an example.
Let's prove.
That is ridiculous. What
if
cowards?
we can show that not P.
Cowards.
All right, so we can conclude the only way this is a true. Well, from last time, the only way this is a true statement.
Okay, so let's look
and
at
so
this
it must
again.
be that it prove if not P implies false is true. Well, from last time, the only way this is a true statement is if this is false, namely P is true. All right?
Right, so if not P implies false, so this is crazy. Am I just like dumb, or I don't know. P has to be true. If not true. So if it's false, implies false is true. Okay, I'm getting it now. So just forget about P. Just plug true or false into there. So not false, which would be true. So not false. So true doesn't imply false because it's true. So that'd be fine. So the only way to make this true would be to make P have to be true. So they say not true, which means false. Not true implies false, which, yes, that is true. So overall, this is true. Okay, I got it now. So let's do like an example here. I'll put this in a different notation later, but so we want this symbol here. So if not P implies false is true. So what does this mean? This means P has to be true in for this statement to be correct, right? Not true implies false is true, right? Not true, this is P, right? Let me make this like blue. Not true, blue, implies, right, I'll make this orange. You probably don't want to see orange on the stream, actually. Let's do green. Magenta, okay, implies, oh, I forgot a line here. Let's say false, right? Let's make false purple, right? Is true. Cool. So not true implies false, and so P has to be true. So P equals true. Okay, I got it. I don't know how they just picked that up just like that. No one in that classroom had a single question. That just is unreal. I don't get that. Let's keep moving here.
So we can conclude that P is true if we can show that not P implies a falsehood. Any questions about that? It's sort of a lot of sort of notation, and if you tell rational. Okay. Let's prove that square root of 2 is irrational. Is irrational. Okay, everybody knows what an irrational number is? That's
okay, we need to put in, no, we probably already know it here, but just to keep everything consistent, and so irrational number, right?
Something that, okay, everybody knows what an irrational number is? That's something that can't be expressed as the ratio of integers. Okay, and probably most people already know that. How many people have not seen a proof that square root of 2 is irrational before? All right, so most of you have seen a proof of that. Good. You know, if you try to do a direct proof of this, it's pretty hard. How do you show there's no way to represent the square root of 2 as integers a over b? But it's very easy if we do a proof by contradiction. Now, when you're doing a proof by contradiction, always start off by saying by contradiction. Write that down.
Okay, so proof by contradiction. I have an example here. Proof underline, right? No. By, oh, we don't want to make that underline. By contradiction, right? Okay, proof by contradiction here.
And then what you do next is you say, I'm going to assume, for the purpose of contradiction, that P is false, namely not P is true. In this case, that would be square root of 2 is rational.
Okay. So in order to do this, we would need to assume, for the purpose, I get this, of contradiction, that square root, I'll put in the symbol later, 2 is rational. So we want to assume the inverse, we want to contradict their statement, right? Just basically what we said. Let's keep moving.
So in this case, here's what we're trying to prove. That's P. I'm going to assume not P, namely that square root of 2 is a rational number. Then I'm going to get a contradiction or a falsehood, and then I'm going to know that P was true after all.
Yep. Gotcha.
All right, so let's see where this leads us. Well, if square root of 2 is rational, then we can express it as A over B, where A over B is a fraction in lowest terms. That means A and B have no common divisors. That means that
Okay, it goes
true
fast,
after
man.
all. All right, so let's see where this leads us. Well, if square root of 2 is rational, then we can express it as A over B, where A over B is a fraction in lowest terms. That means A and B have no common divisors.
Okay, so
And
I'll
then I can
reduce
square
down.
both sides. And I get 2 is A squared over B squared. Then I multiply by B squared, and I get 2B squared equals A squared. And what does that imply about A? What can you tell me about A if it equals, if A squared is 2B squared? Anything special about A? Can A be anything?
A cannot be.
A squared is even, right? Because 2B squared is an even number, so A squared is even. And what does that mean about A? A is even. If A squared is even, then A is even. So A is even. All right, so we can write that as 2 divides A. That's the divide symbol. You'll see a lot of that next week.
Okay, 2 divides A. Okay, I'm getting this so far. I'll go back and I'll put this into notes, but I'm getting
All right,
this
if
so
A
far.
is even, what do I know about A squared? I know more than just it's even.
You know that it's equal to 2B squared.
What is it? It's a multiple of 4, yeah. So that means that 4 divides A squared. A squared is 2B squared, so that means that 4 divides 2B squared. Divide each side by 2 means 2 divides B squared. What does that imply about B?
You blasted through that quick. So A is even. 2 divides A. Right? A divided by 2. Right? 4. We just squared 4A squared.
4, yeah. So that means 2 divides even. A squared is even, right? Because anything? A squared is even, right? Because 2b squared is an even number, so A squared is even. And what does that mean about A? A is even. If A squared is even, then A is even. So A is even. All right, so we can write that as 2 divides A. That's the divide symbol. You'll see a lot of that next week. All right, if A is even, what do I know about A squared? I know more than just it's even. What is it? It's a multiple of 4, yeah. So that means that 4 divides A squared. A squared is 2b squared, so that means that 4 divides 2b squared. Divide each side by 2 means 2 divides b squared. What does that imply about b? B is even. All right, b is even. Good. Well,
Yeah, oh, so this says 4 divides A squared, right? So you square the 2, divide it over. Yes, right? Well, four divides 2b squared as well. Why does 4 divide 2b squared?
4 divides A squared. A squared is 2b squared, so that
A squared is 2b squared, yes.
means that 4 divides 2b squared.
Oh, okay, so I get where it's coming from. So, because you can say, well, you can reduce this down by saying 2 times the squared is 4. And you can move that over and say, okay, well then we can say that A squared is divided by 4 in this scenario. 4 divides A squared. Well, also A squared is equal to 2b squared. So A squared can be represented as 2b squared. So 4 divides 2b squared, right?
Divide each side by 2 means 2.
And then divide each side by 2, which means 2 divides b squared.
2 divides b squared. What does that imply about b?
2 divides b squared. B is also even.
B is even. All right, B is even. Good. Well, I've got A is even and B is even. Have I got a contradiction here somewhere? Yeah, A over B was not a fraction in lowest terms because both A and B are even. All right, so that implies A over B is not in lowest terms. And that gives a contradiction. Now, you'll see that written lots of ways. One is you can say a contradiction. Sometimes you'll see just this sharp symbol written, and that means you got to a contradiction, because here we had it being in lowest terms, and here we have it not in lowest terms. You can't have both at the same time, so you got a contradiction. And that means we've now proved that this assumption was wrong. Square root of 2 is not irrational, is not rational, so it must be irrational. All right, and then we put a little box here at the end, or sometimes you'll see a check, sometimes you'll see QED that says the proof's done now. It's over.
Interesting. Okay. So that took my brain a little bit of working around, but I got it. So just to recap, I wish we could just get a zoom in on this board here. Okay, we can. So over here it says, assume for the purpose that square root of 2 is irrational, right? Or is rational. So we want to then say a part of this proof, let me just do like this. I don't want to do this. Let's have it here, like so. Right? Assume, okay, so then we want to say the square root 2 is equal to a divided by a over b, right? Which is a fraction in lowest terms. So square root 2 is equal to a over b, right? Which is a fraction in its lowest terms, right? Irrational is a fraction in a ratio of integers. So a square root 2 is represented as a ratio of integers. And this is a fraction in its lowest terms, which means it can't be reduced down any further. So does the square root 2, this means then the square root 2 won't reduce a over b down any further, I believe. Correct me if I'm wrong, but please put in something in the comments. Now, that being said, this just said, now this equals, reduced down further, to 2 is equal to a to the power of 2 divided by b to the power of 2. I'll go back and fix this syntax. Right, I'm going to tab over a couple of lines here. I don't know how I'll put it in, but I don't want to write it in italics, yeah. Raised both sides by power of 2 to eliminate. Oops. Okay. And then 2b squared multiply b over, right? 2b to the power of 2 is equal to a squared, right? Cool. And then this, what we did here is we just multiplied b squared on both sides to move it out from the denominator, right? Now we have 2b squared is equal to a squared. Now we can't really do anything further besides just divide 2 back over to a squared, making b squared equal to a squared. But first we'll raise it to a power. Because exponents come before division. So you have to power it. Because it's being multiplied by 2b squared. No, I don't think that that is the principle. I think the principle...
that says box here, both B.
Why is it 4?
I know more than just it's even. What is it? It's a multiple of 4, yeah. So that means that 4 divides a squared. A squared is 2b squared, so that means that 4 divides 2b squared.
So why is... I get that it's a multiple of 4. Two is squaring the b is being squared, not the 2. So it's not the 2 squaring over here. Why? What's the multiple of 4 coming up? It's probably simple, I'm just not wrapping my head around it. Why a is even? 2 divides a. Okay, let's put that, right? So a is even. Right? 2 divides a. So this by moving divide both sides by 2. Both sides by 2. 4 divides a squared. I'm not sure why. 4 divides 2b squared. So then this reduces down to 2 divides b squared, right? And then b is even. A divided B is not in lowest terms contradiction. So what do I want to do? Square root here. So I'll come back and fix that. X. I'll make a comeback for this. And then you want to do like a box thing. Okay.
And that means you got, and here we, and square root of 2 is, we've now.
I'm going to give me Mr. Like that guy in here. You're presenting a proof by contradicting to show that square root of 2 is irrational, and you're very close. Let me help you refine it slightly. Assume 2 is rational. That means we can express square root of 2 as a over b, where a and b are integers and their fractions in its lowest form. A and b have no common factors other than 1. Square root both sides to remove the root. Right. Multiply both sides by square root b to eliminate the denominator. This means that a squared is even because it's equal to 2 squared b, which is even. Yep. This means that a squared is even because it's equal to 2 squared b, which is even. 2 times b. Two b's. Since a squared is even, a must also be even. Because the square of an odd number is odd. No, this is wrong. The square root of an odd number is even. Not square, because the square of an odd number is even. That's wrong. Therefore, we can write a equals 2k for some integer. Substitute a equals 2k into the equation. V square root 2 equals 2k, square root 2 implies. What? This is tricky. Fractions in its lowest terms, a and b have no common factor. Square both sides to remove the square root. Is equal to 2 squared, which is even. Break it down further. Start by assuming the opposite. Choose rational. We can write it as a fraction, where a and b are integers. Yep. Square both sides and then make the square root. Now both sides. Square both sides to eliminate. Now square both sides of the equation and remove the square root. Yep. So now we have an equation involving the squares of a and b. Multiply both sides by b to clear the denominator. To remove the fraction, we must multiply both sides by b squared. This equation tells us something very important. a squared is equal to 2b squared, which means that a squared is an even number because it equals 2 times some number. So anything times 2 is an even number, I guess. That's a property. This is 2. Oh, okay, so yeah. Anything times 2 is, okay, even. So okay. So multiply both, move the denominator. A is even. Now divide both sides by 2. A to the power of 2 is equals b to the power of 2. B to the power of 2. Anything any integer multiplied by 2 is an even number. Right? If a squared is even, that must mean even. Why? Because the square root of an odd number is always odd. Oh, sorry, yeah, always odd, I meant that. Okay. Any integer multiplied by 2 is an even number. Therefore, a squared is equals even number. Right? So if 2 times b squared is an even number, then that is equal to a squared, so a squared is also equal to number. If a squared is even, then a is even square root of an even. Yeah, right? The square root an even number is always even, right? No, the square root of an even number is not always even, however, in the context of this solution. the square. No, not the square. Is that what it's meant? No, the square. Sorry. Even number is always even. Yes, the square. That's right. Even number integer is 2k. An even number is any integer that can be written as 2k, where k is some integer, even as number of decimals. So 2k squared equals 2k times 2k. The result is 2k is 4k squared. You could divide by 2, in effect 4, so it's even. 4, so it's even. So if it's divisible by 2, it's also divisible by 4. It's also divisible by 6. It's a multiple of, I mean. So if a squared is even, then a is even, because a is even, because even no, that wouldn't technically prove it, because the square of a could be 3, then a is even because a is even because odd numbers squared are always odd. Right, as I always said earlier. Square of an odd number is always odd. A is starting, okay, because the square of an odd number is always odd. So if a squared is even, it has to be even. A has to be even because if you square an odd number, it's an odd, and a squared is not odd. A is even because square of an odd number is always odd. A squared is not odd, therefore a is even. Okay. So a squared, which is 2a, why I don't get this part. So b is 2k. Oh no, it's squaring the entire thing. I was right, yeah, it's squaring the entire thing. So 4k squared. B squared equals 2k. So that's a b squared is even. Okay. Let's do it a different way. So I've been streaming for almost an hour and I've only gotten 10 minutes into this thing. Oh my god. This part is crazy. I think that there was a comment. I think the center square. Right, so now substitute 2k in the equation. I get this 2k part. I'm trying to wrap my head around this. 4 is a multiple of a squared, so 4 divided by a squared. I'm pretty sure it's just because he did this. It's b squared, b 2b squared, so it's 4b. It's 2b squared plus times 2b squared, which would be 4b times 2b squared. Yeah, divided by 4. Okay. Yeah. Okay, I get that. Going to end the stream here. I pretty tired. Wrapping it up. I released some problem here on the Python crash course problem. Try it yourself. So go check out that video. But trying to wrap my head. I think I get this. So if this 4 represents this 2 being squared by this, right? Because this is what this means, right? This is what this means, right? So the whole thing is being squared, not just the b. So the 4, it'd be 2b squared times 2b, or 2b times 2b is equal to 2b squared, right? So which would equal to be 4b squared, where the b is only squared. All right, we divide the 4 over. That makes b squared is equal to a squared over 4. Yeah. B squared is equal to a squared over 4. So oh, because if a squared is also equal to 2b squared, so 4 also has to be divisible, b2 also has to be divisible by 4 in this case, reducing that down further to b squared divided by 2. Okay, get it. So, 4 is divided 2b squared is 2b times 2b which is 4b squared times b squared substitute for that looks better. 2b squared is 2b times b, which is 4 times 2b squared. Substitute um, 4 times b squared for 2b squared. So it's 4 4 times b squared is equal to a squared, right? Want to divide both sides by 4. So they need to put this up here. Equals, which equals 4b squared right? 2b squared is equal to 2b. b squared is equal to equals to 0b. So that takes care of this issue here. So now this one, 4 divides b squared 2b squared. We said that right, we said the this guy 2b squared equals a squared. We substitute 2b squared. Oh no. If 2b squared is equal to a squared, right? Then 2b squared is also then 4 divides 2b squared, right? Okay. Now we would just reduce this down. Divide, reduce, down, fraction. Reduce fraction, right? And then b is even because b, 2 divides b. Not because so if 2 divides a means a is even. Yes, that's correct. 2 reads 2 divides a, which means that a is as well 2, which and just an even number. Okay. Reduce fraction, right? Reduce it down. We said earlier that a squared divided by 2 is even because if a squared is even, any integer multiplied by 2 if a squared is even, then a is even, because the square of an odd is always odd, right? We need a squared to be even. If a squared is even, b, and what about b squared? B squared means the expression b squared divided by is no 2 divided by b squared. Expression 2 divided by is 2 divides b squared means that b is divisible by 2 without leaving a remainder there. This important implication regards to b. If 2 divides b squared, it implies that b squared is an even number since it can be divided by 2. If b squared is even, it means that b itself must also be even. Supposed to be like this, right? A is even, b is even. So here, this one. So b squared b squared is divisible by 2 right? If b squared is even, meaning b squared is even, therefore b squared is even. If b squared is even, then b is even because the square of an odd is always odd. A squared is not odd, therefore a is even. So if a squared is not odd, a has to be even, because if a was to be an odd number, the a squared would be odd as well, right? iso then b is even. B squared is not odd, therefore b is even. So the contradiction is we've shown that both a and b are even, meaning they're both divisible by 2. But this contradiction assumes that a divided by b is in lowest terms. If a and b are even, then they share a common factor 2. So the fraction a and b is not in its lowest terms. Because it both a and b are divisible, are even, meaning they are both divisible by 2, right? Both a and b are even, meaning they're both. So even if they share a common factor of 2. I'm gonna give it this, see what it says. Okay. Alright, I'm gonna call it there, everybody.